Question 10, Part A. The diagram below shows a parallelogram and its two diagonals. So this is the parallelogram. So it's a four-sided shape, or a quadrilateral, which means four-sided shape, that has two sets of parallel lines. So parallel lines are lines that never meet. So this line is parallel to this line, it's going in the same direction, and this line is parallel to this line, it's also going in the same direction. And it has two diagonals, and a diagonal is a line that cuts through the top right corner and the bottom left corner, and the top left corner and the bottom right corner. So this is the parallelogram, and these are its two diagonals. Some of the angles in the diagram are marked. So we have 110 degrees, 30 degrees, 40 degrees. Write down the size of angle K and the size of angle L. So first of all, angle K is 110 degrees. And the reason is opposite angles are equal. So we can see angle K and 110 degrees are opposite each other. They're vertically opposite each other, and vertically opposite angles are equal. So we can see vertically opposite angles in an X shape. So, for example, here we have an X shape, and this angle is vertically opposite this angle, so they are equal. So those two angles are equal. And then this angle is vertically opposite this angle, so those two angles are also equal. So vertically opposite angles are equal. So 110 degrees in K are equal, and likewise these two angles are also equal, but we're not interested in those angles for the moment. So then we want to figure out what angle L is. So angle L is going to be equal to 30 degrees. And the reason for that is alternate angles are equal. So angle L and angle 30 are alternate to each other. So alternate angles can be seen in a Z shape. So this is a Z shape. And we can see that this angle and this angle are inside the Z's. So they are equal to each other because they are alternate. So here I've drawn out two parallel lines. I've got two little arrows showing that they're going the same direction, which means they're parallel. And I'm going to draw in a transversal, which cuts through them. And alternate angles on a transversal inside parallel lines are going to be equal, just like alternate angles inside a parallelogram will be equal. So, for example, this angle here and this angle here, they are alternate to each other, so they are equal. So angle L and angle 30 are alternate to each other, so they are equal. So angle L is equal to 30 degrees. Likewise, if we had been looking for this angle up here, this angle would be 40 degrees because it's alternate with 40. But we weren't actually looking for that angle, we were only looking for angle L. Part B. There are four statements in the table below. Number 1, in a rectangle, the opposite sides are equal. Number 2, the sum of the four angles in a rectangle is 180 degrees. Number 3, a square has four axes of symmetry. Number 4, each of the angles in a parallelogram is 90 degrees. Part 1. Put a tick in the correct box on each line to show whether each statement is always true, sometimes true, or never true. So if a statement is always true, we put a tick into these boxes. If it's sometimes true, we tick these boxes. If it's never true, we tick these boxes. Very, very important that we only tick one box for each statement. So statement number 1, we tick one of these boxes. Statement number 2, we tick one of these boxes. Statement number 3, we tick one of these boxes. Statement number 4, we tick one of these boxes. Statement 2 in the table above says that the sum of the four angles in a rectangle is 180 degrees. So the sum of the four angles in a rectangle is 180 degrees. Part 2, justify your answer to statement 2. So justify means explain and back up your answer to statement 2. So whichever box you tick for statement 2, you need to explain the reason why you picked this box. So statement 1, in a rectangle, the opposite sides are equal. This is always true. The opposite sides in any rectangle are always going to be of equal length. Statement 2, the sum of the four angles in a rectangle is 180 degrees. This is never true. The angles of any quadrilateral, so the angles of any four-sided shape, will always add up to 360 degrees, not 180 degrees. Statement 3, a square has four axes of symmetry. This is always true. A square has four lines of symmetry that can be drawn into it. Statement 4, each of the angles in a parallelogram is 90 degrees. This is sometimes true, because if we had a square or a rectangle, that is technically a parallelogram, because the opposite sides in a square or a rectangle are going in the same direction. So technically, a square and a rectangle are actually parallelograms, and the angles of a square or a rectangle are each 90 degrees. So statement 2 in the table above says that the sum of the four angles in a rectangle is 180 degrees. And we ticked this to be never true. We need to justify our answer, so explain our answer. So statement 2, the sum of the four angles in a rectangle is 180 degrees. This is never true. And the reason for that is the four angles in a rectangle are each 90 degrees. So here's a rectangle, and each corner has an angle of 90 degrees. And the sum, which means add, the sum of these four angles is 90 plus 90 plus 90 plus 90, which equals 360 degrees. So 90 plus 90 plus 90 plus 90 equals 360 degrees, not 180 degrees. So the sum of the four angles in a rectangle is 180 degrees is never true.